Hi guys, so today I want to show you how to solve a 3-variable linear equation using Gauss-Jordan method. Let's go. So here guys, we have a 3-variable equation. So this is my example. 3x minus y plus z equals negative 4. X plus y plus z equals 2. 2x plus 3y plus 4z equals 8. So as we notice that there are 3 variables, the x, y, and z. But this is really not important. It can be a, b, c, or x1, x2, or x3. So the x, y, and z here, the variables, are really not that important. So okay, let's start. So first, we will make this in matrix form. So we have here, I will just indicate to you the row 1, row 2, and row 3. Okay? Row 1 will be this first equation, 3, negative 1, another one here for z, and for the negative 4. Okay? Next, the second equation is 1, 1, 1, and 2. Third and last is 2, 3, and 4, and 8. So, we have now here the equations in matrix form. Note that in Gauss-Jordan method, we have to make this a 0 and this. So we have to make this 0. And here in the middle, we have a diagonal. We have to make this as 1. In short, our goal here is to have an identity matrix, meaning 1, 0, 0, 0, 1, 0, 0, 0, 1. So that is an identity matrix. Okay, so let's proceed. First, our goal is to make this column, like R2 and R3, to be 0, right? The best way possible to do a Gauss-Jordan method is that if we want to change R2 or R3, for example, we must make R1 be a smaller number than R2. The same as R1 must be a bigger number than R3. Okay, let's start. So, we can swap R1 and R2. Okay, R1 swap for R2. So we can have this as, okay, R1 swap by R2, 1, 1, 1, and 2. Okay, so 3, negative 1, 1, and negative 4. And as is for R3, 3, 4, and 8. Okay, so we can now add or multiply this so that we can have R2 as 0 and R3 as 0 in the first column. So if we want this to be 0, we have to multiply R1 and add it to R2. So the best way possible is negative 3 times R1 plus R2 if we want to change R2 as 0. So our formula here is negative 3 times R1 plus R2 is equal to R2. Okay? And we can also do this in R3. It will be negative 2 times R1 plus R3 is equal to R3. Okay, let's do that. We will just have another matrix form here. We will R1 will be as is. We won't change R1 here. So the one will be changed is R2 and R3. Okay, pull out our calculator. Negative 3 times R1, which is 1, plus R2, which is 3. The answer will be 0, right? So this part here will be 0. Okay, so for the second column, we have negative 3 times 1 plus negative 1. It will be negative 4. Okay, so we'll have just to do the process again and again for column 3 in row 2 and column 4 in row 2. So we have now the row 2 changed. So As we can see, it is now 0 in column 1 in row 2. So the next goal is, in column 1 in row 3, we have to make this 0. So again, we have the formula of negative 2 times R1 plus R3. You just have to plug in the numbers. R1 is 1, R3 is 2. So it is 0. So now, in column 1, we have 2 zeros, right? So these right here are now zeros. So we have to just do the computations in column 2, column 3, column 4 in row 3. Okay, so it is now complete. So we have now the 2 zeros in column 1, in row 2 and row 3. Next, as we can see that we have to make this a 0, right, in column 2 and in row 3. So as you can see that row 2 is a smaller number or a value of a number than row 3 because it is negative. So we can swap this. Okay? So let's swap R2 and R3. We can now have, we now have a different matrices in R2 and R3. Okay? So now we have to make this a 0, right? This negative 4. Okay? So our formula will be 4 R2 plus R3 if we want to change R3 to 0 because it is negative 4. Okay, let's do another matrix here. R1 and R2 will be the same, and R3 we will change R3. Okay, so 4 times R2 is 1 plus R3 is negative 4, right? It will be 0. So this will be 0. Okay, because this is 0. Okay, let's look at it. 4 times R2 is 0. This will be 0 plus R3 is 0. So 0 and 0. Again, we just have to plug in the values of this formula. So this is now, we now have a 3-0 here, 0, 0, 0. So we are left with 1, 1, and 2. We have to make it a 0. So next, the best way to do is we have to make this diagonal as 1. So we can see here that this is 6. We just have to divide it by 6 to make it 1. Okay? So it will be R3, 6 divided by 6 is 1, right? Then here, 6 divided by 6 will be 1. So this is our new matrix. So next, our goal will be to make this a 0, 0, and 0. We have a formula of negative 2 times R3 plus R2, and this will be our new R2. Another one is 1 times R3 plus R1, and this will be our new R1. Okay, so we'll have another matrix here. R3 will be as is, and 1. Okay, in R2 we will change it as negative 2. We will plug in the values. Negative 2 times R3, where's R3? 0, right? Plus R2, 0, it will be 0. And then negative 2 R3 is 0 plus 1, it will be 1. And here, negative 2 times R3 is 1 plus R2 is 2. This will be 0. Okay, negative 2. So this will be 0. So same thing, same process. This will be 2. So sorry, this is negative 1 right here. So negative 1 times R3 is 0 plus 1 is 1, right? And then in column 2, negative 1 times 0 plus 1, this will be 1. And negative 1 times 1 plus 1 is 0. Okay, then negative 1 times 4 is negative 4 plus plus 2, this will be 1. Okay, so we are now finished here in column 3. So the last thing to do in column 2 in row 1, we will make this a 0. So we have a formula to make this a 0, negative 1 R2 plus R1, and we'll make this a new R1. Okay, so this is now the continuation of our solution. Row 3 will be the same as row 2. So we have the formula of negative 1 times R2 plus R1. So negative 1 times R2 is 0, plus 1 is 1. Negative 1 times 1 is negative 1, plus 1 will be 0, right? And negative 1 times 0 plus 0 is 0. So negative 1 times 2 is negative 2, plus 1 will be negative 1. So as you can see, we now have the identity matrix, diagonal in 1, and here in the side are all zeros. So we are now done in our solution. We now have, this is the R1, right? So this right here is X, Y, and Z. So it's all clear that X is equal to negative 1, Y is equal to 2, and Z is equal to 1. So X is equal to negative 1, Y is equal to 2, and Z is equal to 1. So these are now our final answer. Okay, we can check this in our calculator to prove that our answer is correct. So first, we had to go to mode or setup, find the number 5 for Casio FX 570 ES Plus for equation, and choose number 2. Okay, so for our linear equation, first linear equation is 3x. This will be 3, negative 1, 1, and negative 4. Second linear equation is 1, 1, 1, and 2. And the last is 2, 3, 4, and 8. So just click equal. We can now have, as we can see, x is equal to negative 1, right? Y is equal to 2, and z is equal to 1. So there you have it, guys. That is how you solve using Gauss-Jordan method. Thank you for watching.